Good afternoon. Welcome to Science Bonanza. Today we are going to look at a parallel circuit. So we are focusing on the parallel circuit from basic science for grade 8. In our circuit here, what we've got a battery that is made up of 4 cells. Each cell is 1,5 meter. From there, what we have connected now, it is our switch. Now, our switch, Siabona switch, that's where we are going to connect our circuit. We are going to be able to on and off our circuit. So now, after the switch, we have connected a conductor. So we've got a parallel branch here. So the electrons will travel and go there, and they will split. So this point is a split. It's a split point. So current is going to divide. Some of the electrons will go to light bulb number 1. Some of the electrons will go to light bulb number 2. Some of the light bulb will go to light bulb number 3. After that, they will combine again, then go through the ammeter. This is our ammeter. It's just an equipment we use to measure the flow of charge. So the current come in here through the negative, and they come out there through the positive terminal. So we connect it in series. It's just like holding arms like this. So after that, all the electrons now go back to a battery. So a battery has got what? Potential difference. It has got energy, potential energy. So it pushes. So right now my circuit is open. So inside this battery, I've got what? I've got chemical potential energy. So the moment I put my switch on, that chemical potential energy is converted into electrical energy, which then pushes the electrons to go through all of these 3 different light bulbs. So now let's have a look at what is the current here in my ammeter when I connect one light bulb. Let me just disconnect one light bulb there, disconnect the second light bulb. Now I've got what? A light bulb A order. One light bulb. Let us look at what is the ammeter. So we can see that it is very bright, and the current there is 280. Well, I can't see it clearly. 280 milliamperes. Let me change the scale and put it there on 300 so that we can see it clearly when it moves. So let's have a look at it. So we can see there it is a 300 milliamperes. Now let me connect second light bulb. When I connect second light bulb, let's have a look at what happens to the current. Now we notice that our current is over the maximum scale of 500. So I must change my scale there, and I take it to a higher scale. So we normally say you must start with the higher scale and see what happens. Now, let's look at our ammeter there. So we can see that our ammeter let me have a look. It's a 480, not 480. What is it? Yes, close to 450. 450 milliampere. Remember now that I have moved it from a lower scale of 500 milliampere. Now I'm using 5 amperes. So 1000 milliamperes is equal to 1 ampere. So to move from amperes to milliamperes, you will divide amperes by 1000. Right. Let's have a look at when the third light bulb. Let's look at it. Now we notice that our current is now 600. Let's have a look at it. It's now more than 500. You can see it there, 0.5. So 0.5, we're looking at that top scale. That top scale, it says 4, 3, 2, 1. So you can see there, it is close to 600 milliampere. So what we have noticed here for now is that when we keep on adding more light bulb in parallel, it is like we are increasing more pathways. So it is easier for the electrons to flow. Now we've got 3 pathways. So when it is easier for the electron to flow, we will have more current going in. This is what is happening in our supermarkets. Month end, it becomes very busy. So they decided that we must just open more cashiers. Right. Now what we need to do is to look at the voltage. We want to know what happens when we connect more light bulb in parallel. What happens to the voltage? Now we start with the first one. We use our multimeter. We check what is the current coming from our light bulb there, coming from our battery. So we can see that our battery is giving 3,9. So if it is 3,9, let me bypass my switch because I'm alone here. Let me bypass my switch. So now it is on. So you see the voltage coming from the battery is 3, is 1,72. 1,72, 1,75. Then let's go to light bulb number 1. Right, oh yeah, there we go. Oh no. Came off, but never mind. Oh, let me use the other one. So it helps to have more than 1 meter. Thanks to my principal for buying me many meters more than I need. Right, so let's have a look at our voltage. Is 1,68 for my battery. Now let's go to light bulb number 1. 1,43. Light bulb number 2. Light bulb number 2. Let's have a look at it. 1,46. The first one. 1,43. 1,45. 1,48. 1,43, 1,45, 1,48. It's just a little bit of a difference. But what we see is that along this parallel branch, so along this parallel branch, we see that sorry about that. So along this parallel branch, we see that the voltage is the same. So let's have a look. Voltage on bulb number 1, 1.37. Let's have a look at it. Voltage on bulb number 1, 1.36. Bulb number 2, 1.40. Bulb number 3, 1.36. So it is almost the same voltage that we see there. So we can conclude that the more light bulb we connect in series, in parallel, the more pathway for the electron to flow. And the resistance will now be, so we see that the resistance, it becomes less because now you're opening more pathways. So we have a look at it. We say right. So we say current travels here, goes into the switch, comes here. At this point, it is a parallel branch. So some electrons go into light bulb number 1, some goes into light bulb number 2, some goes into light bulb number 3. So let us be aware of that. And sabona yini okunye uthi akhanya ngokufana, the brightness is all the same because the potential difference is the same across the parallel branches. Remember, you can measure the power for each light bulb. Power equals to VI, voltage multiplied by current. If the voltage is the same here, and these light bulbs are identical, the rating of this light bulb is 2.8 volts. So remember, in science, when we are doing an experiment, there are some variables that need to be fixed. So you can't compare an apple with an orange. So this light bulb, ayafana, they've got the same rating. So under the same rating, obviously they will have the same resistance. Now, let's have a look at the series circuit. We're going to build a series circuit quickly. Let's have a look at what happens. Going to look at the series circuit. Let's have a look at it. Series circuit. So, what do we have there? We've got a parallel circuit. Let's break it. Let's make it a series circuit quickly. So to break it, so in order to break it for me, I just simply do this. So let's do this. Right here, over there. Here we go. So we have got only one pathway. What do we see? If it is just one light, three are connected, what do we see? They are very dim. Why? Because in a series circuit, we say current is the same throughout. Current is the same. So now, let me move my ammeter to the 500 milliampere. Let's have a look at it. So my current flow in there, it's roughly around 160 milliampere. So now, let's have a look at this path. Let's analyze it. So it is current travels. The battery pushes the electrons. The electrons, they flow, they come into the ammeter, and the ammeter measures how many electrons are flowing, and then we go all the way to light bulb number 2, number 3, number 4. Now, what we need to do, we need just to bypass the the, the first light bulb. I'm gonna use this. What do we have? We have got one light bulb because the current travels here all the way into the ammeter, all the way to light bulb A, then all the way to this side. Right. Now, all right. Okay, can put it like that, or we can also put it the normal way that it will be easier for some of you to understand it. So we have it like that. Connect that one over there. That one there. So that one there. All right. You can see our circuit is now complete. Now I'm just going to need one wire there. I just need to bypass my switch in order to choose one light bulb. If I choose one light bulb, what happens? What is the current? My current is 260 milliamperes. Let me make sure that you can see that. So my current is 260 milliamperes. You can see it over there. Now, while it is still there, let's measure the voltage. Where's my ammeter? Where's my voltage? Where's my voltmeter? Right, let's go. So remember how we connect it? We say red to red, black to black. So it's my voltmeter. Where did I put it? Did I put it at the right place? Yes, I put it at a 20 voltmeter. So let's have a look at, let's check our battery. How much is it supplying? Negative to negative. So it's negative to negative. So this is a black one. It comes in here, and the red one comes in there. So my battery is supplying, my battery is now currently supplying 2,32, and my current is 260 milliamperes. Let's connect two light bulbs. Remember, it was bright. Let's connect second light bulb. When I connect second light bulbs, we notice that the current is now, the voltage is now shared between the two. Let's check how much is, and it is dim. Let's check the voltage supplied by my battery. Put my battery close so that we can all see it. Let's put my ammeter close as well. Right. So my battery is supplying 2,52 volts. So we expect that 2,52 volts coming from the battery to be divided equally among those two light bulb. Angithi yafana nasekhaya, when your younger brother get born, now you share that money that your mommy used to give you ukuthi uyodla esikolweni. So you share because you belong to the same mother. Now let's have a look. To tell the voltage here is how much? 2,5. I expect 2,5 divided by 2, around 1,2 for one of them. That's what I expect. Let's have a look. Can we see? Now I'm hiding it. So we can see 1,04 for the first one. So 1,09, the first one. So the here is 1,04, and there is 1,12. So what we have seen there is that this voltage, when it was coming from the battery, it was 2,5. Now it is going to two light bulbs that are connected in series. So we have seen that voltage become divided when we connect resistors in series. What happened to the current? Initially, the current was 260. Let's look at our ammeter. So our ammeter says that my voltage is now 230 milliamperes. Now let's go now and connect three light bulbs. What happens to current? We see that it went down. So let's check the voltmeter. Let's check the voltage for light bulb number 1. Let's check voltage there. The voltage there is how much? So the voltage there for the first one, so the voltage there for the first one, it was 0,73. For the second one, 0,66. For the third one, 0,75. We can see it there. Let's switch off my light. We can see 0,75. So all that voltage is coming from where? From our battery. Our battery gave us 2,6. So you divide that by 3, you are more likely to get around 2,73. 0.73 is really 0.66. The last one 0,76. And what happened to the current again? It went down. So now, children, what we need to understand now is that the more we connect resistors in series, we are increasing the resistance. It becomes more difficult for the electrons to flow through each successively connected components. So what happens to voltage? Voltage also becomes divided among each of the component. So our component lawa ayashare. They dividing what? The voltage. The voltage which come from what? The voltage which come from the battery. And what we also see with the current, we saw that the current also went down. It kept on going down. So it was 260, then it went down, then it went down, and it went down. So it's because it is more difficult for electrons to flow. And also in a series circuit, we have got one pathway. There is only one pathway. So there is only one pathway. Hence, it becomes difficult for the electrons to flow because now they encounter resistance here, and they also encounter resistance go cell number 2, and when it passes here, it does the work. So when you want to measure voltage, you connect the ammeter here, the voltmeter, I beg to say, and also go light bulb number 3, so the current is dropping. Whereas on the parallel circuit, what we saw, the current kept on going up. So let us make sure that we are aware of those fundamental differences between the two circuits.